All right, let's dive into one of the biggest, most sought-after prizes in all of science. We're talking about the monumental quest for a room temperature superconductor. It's the holy grail of modern physics, and it could change literally everything. I mean, just stop and think about that for a second. What if every single bit of energy we generated actually got to where it was going, with zero loss? What if your phone, your computer never heated up? What if we could make things float, just on command? That's not science fiction. That is the very real world promised by this incredible physical phenomenon called superconductivity. It's a state of matter that could fundamentally rewrite the rules of our entire technological civilization. So, why is this so important? Why is this the prize? Because finding a practical room temperature superconductor wouldn't just be an upgrade, it would be a complete and total transformation of society as we know it. We're talking about a world with power grids that don't waste a single watt of energy. Imagine ultra-fast maglev trains that float frictionlessly, hitting unbelievable speeds. Quantum computers, which right now are these giant, complex cryogenic systems, could become way more practical. Even the everyday electronics in your pocket could become thousands of times more efficient. And take a look at this. This gives you an idea of just how big a deal we're talking about. This maps out how a system built with room temperature ambient pressure superconductors, let's just call them RTAPs, could revolutionize everything. Our current power grids are leaky. They waste so much energy as heat because of resistance. A superconducting grid, it would plug that leak completely. And that waste is just staggering. Every single year, electrical resistance in our power lines is responsible for 949 million metric tons of CO2 equivalents. That is an enormous amount of energy and pollution created for absolutely nothing. All that energy just poof, gone as heat. It's a problem that superconductivity could solve, like, overnight. So how does this magic actually work? To really get why the prize is so huge, we have to understand the physics. What is it that makes a superconductor so, well, super? This chart breaks it down beautifully. Okay, so in a normal wire, like a copper wire, think of electrons like a crowd of people trying to shove their way through a packed hallway. They're bumping into each other, bumping into the walls, creating friction and losing energy as heat. But in a superconductor, something amazing happens. The electrons pair up into these things called Cooper pairs. These pairs move together in perfect harmony, flowing like a superfluid with absolutely zero resistance. A current you start in a superconducting loop could literally flow forever. But zero resistance is only half the story. The other critical piece of the puzzle is something called the Meissner effect. See, a superconductor doesn't just block a magnetic field, it actively kicks it out from its insides. This is what's known as perfect diamagnetism, and it's the powerful repulsive force that lets a superconductor float above a magnet. To be a true superconductor, a material needs both zero resistance and the Meissner effect. No exceptions. Now, because this potential is so world-changing, you can imagine what happens when a new claim comes along. The scientific world basically explodes. And nothing, I mean nothing, illustrates this better than the recent, wild saga of a material called LK99. So, in July of 2023, the internet just went nuts. Researchers published papers claiming they'd finally done it. They'd created a material that was superconducting at room temperature and normal air pressure. Then a video dropped, showing this little flake of the stuff, LK99, seemingly levitating. It went viral. For a few wild weeks, it felt like the future had finally arrived. But then, as labs all over the world scrambled to replicate the results, the whole dream started to fall apart. I mean, listen to the claim they made. Opens a new era for humankind. You can just feel the massive excitement and the incredibly high stakes in that one sentence. It's what everyone in this field has been chasing for over 100 years. Well, here's the thing about science. It needs more than a cool viral video. It demands reproducibility. The rule is, if other scientists can't follow your recipe and get the same result, it doesn't count. And as lab after lab failed to see what was claimed, that initial excitement turned into some serious scientific scrutiny. Extraordinary claims require extraordinary evidence, right? And for LK99, the evidence just wasn't there. But the whole LK99 roller coaster brings up a much deeper, more fascinating question. What if the reason we're struggling so hard to find these materials is that our scientific map, the very theory we're using, is incomplete or maybe even flawed? For decades, the main playbook for explaining how conventional superconductors work has been something called BCS theory. Basically, it says that at super cold temperatures, electrons can use vibrations in the material's atomic structure. Physicists call these phonons to link up into those Cooper pairs we talked about and then flow without any friction. But as some physicists like J.E. Hirsch have been pointing out, there are some pretty big red flags. For one, BCS theory is notoriously bad at actually predicting new superconductors. It also has a really hard time fully explaining that all-important Meissner effect. And it kind of stumbles when it comes to the growing list of unconventional superconductors that just don't seem to play by its rules. It's a reminder that science is an ongoing debate, and our map might need a serious update. But here's the cool part. While the whole world was watching the LK99 drama on social media, real, verified progress was being made in labs far away from the hype. It's just happening under much, much more extreme conditions. And this really gets to the heart of it, the hype versus the reality. The dream of LK99 was the whole shebang, room temperature and normal, ambient pressure. The reality of today's cutting-edge research? We've hit room temperature, yes, but only at insanely high pressures. And the most important difference? The reality is verified. It's reproducible. And that brings us to a genuine breakthrough. In recent years, a research group made a historic announcement confirming a reproducible case of room temperature superconductivity. The material was a type of lanthanum scandium hydride, and it was a huge step forward. But, and this is a huge but, there's a catch. To get this material to superconduct, it had to be crushed with a pressure of over 1.9 million times the atmospheric pressure you feel right now. To put that in perspective, that's just an unimaginable amount of force. So while it's a monumental scientific win, it's not exactly practical yet. The real Holy Grail is still a material that works without being squeezed in a diamond vise. So, where does all this leave us? Well, the dream is very much alive. The science is charging forward, but the final and most difficult hurdles are still ahead of us. You can think of it like a checklist for changing the world. First up, achieve superconductivity at room temperature. Well, check. We now know that's physically possible. But the next item on the list, achieving it at ambient pressure, that is the big one. That's the mountain everyone is trying to climb. And after that comes the practical challenge, figuring out how to make these materials easily and cheaply enough to actually build with them. And that's why scientists are not giving up. The search is relentless, happening in labs all across the globe. And it's all driven by the knowledge that unlocking this secret could be one of the most important discoveries in the history of humanity. So the dream of a world without resistance, it's not a fantasy anymore. It's a verified possibility, even if it's currently locked behind a wall of immense pressure. The ultimate question remains, the one that keeps scientists up at night. What discovery, what new theory, what sudden flash of inspiration will be the key that finally unlocks this future for all of us?